Namaste everyone, welcome to my class. So today we are going to discuss about Rutherford alpha particle scattering. So it is one of the attempts made by Rutherford in 1911 to study about the structure of atom. So we are going to learn about Rutherford alpha particle scattering in 3 or 4 different steps. The first one is the experimental setup. The second one we are going to get the observations, what observations Rutherford made out of this experiment, and the third one is the conclusions of Rutherford, and the last one is from the conclusions the design of the atom or the design of the model of the atom. Right now we will go with the alpha particle scattering. What exactly are the alpha particles? Alpha particles are positively charged particles, so which carries a charge twice the charge of a proton and whose mass is 4 times the mass of proton. Mass is 4 times the mass of proton, or you can say 4 times of u, or 4 times the mass of proton. So how is he able to get this alpha particles? So for this he choose the source as radium. Radium continuously disintegrate to form radon emitting alpha particles. So they are like, exactly we can say the alpha particles are the nucleus of helium, which have the double charge of a proton and 4 times the mass of the hydrogen atom, or 4 times the mass of a proton. Right now the experimental setup is like this. He took the source and placed it in a thick shield of lead. So lead prevents from harmful radiations which are emitted from the radium. Then the shield was provided with a small cavity from which the alpha particles are emitted. To get a thin beam of alpha particles, he has placed slit in between. So this slit will allow thin beam of alpha particles to fall on the gold foil. Now then this gold foil, to observe the scattering or to observe the impact of this, after impact of the alpha particles with the gold foil, he coated the screen with zinc sulfide. Now what is the reason for choosing the gold foil? Gold is the most malleable metal. As a result, he made a gold foil, approximately it is of 1000 atoms thick. Right now when this gold foil is bombarded with the alpha particles, he observed that most of the alpha particles pass through the gold foil without any deflection. Almost we can say 99.99% of the alpha particles went or passed through the gold foil without any deflection. Very few of the alpha particles deflected with small angles, very few, and almost 1 out of 12,000 1 out of 12,000, so very less, 1 out of 12,000 of the alpha particles suffered greater angles on getting impact or on impact with the gold foil. So this is what is the experimental setup, and observations are those. So experimental setup, you are able to follow this. Observations are most of the alpha particles pass through the gold foil without any deflection. Very few alpha particles suffered minor deflections, and 1 out of 12,000 alpha particles suffered greater angles, or almost it retraced its path entirely. This is the experimental setup. We'll go with the observations. So this is what is the idea behind the alpha particle or his observation. So we'll go with the observations. What he observed is, this is 1000 atoms. This is, let us suppose, right now I have drawn 3 atoms thickness left. 1000 atoms thick. Most of the alpha particles passed through without any deflections. Very few alpha particles deflected a little, and those maybe 1 out of 12,000 suffered greater angles are completely rebounded. So it is his assumption that is what would have happened when the alpha particles passed through these layers of atoms. So we'll go with the conclusions. After seeing the alpha particle scattering, Rutherford was very much surprised. Rutherford is very much surprised. What did he expect to? Since he thought that he is scattering the gold foil with heavy nucleus or heavy positive charge, so he thought that there wouldn't be any deflection and it would easily pass through the gold foil. If the deflection takes place also, the angle would be very less, because the protons which are present inside the gold foil are less denser, as well as do not carry that much charge as that of the alpha particles. So he, according to him, he would have assumed that most of the alpha particles would go straight to the gold foil or would suffer very little deviation. But to his surprise, he found that there are some alpha particles which even retraced the path or suffered greater angles. So he was very surprised. After his observations, so he concluded, conclusion of Rutherford. So for him, since most of the alpha particles passed without any deflection, so atom is, most of the space inside the atom is empty or vacant. Since very few alpha particles suffered deviation, so to him, according to him, very few alpha particles have suffered deviations. It is due to the positive charge only, the positive charge. So it would be the repulsion from the positive charge, and that positive charge would occupy very less space. So all the positive charge would occupy very less space, and the one which suffered greater angles, so the one which suffered the deflection with a greater angle is due to the reason that the positive charge which occupies very small area in the atom has very high density. That means the entire mass of the atom is concentrated in this small positive charge. So from the observations, he draw this conclusion. So he thought that the atom has a lot of empty space, and since most of the alpha particles, that is, since most of the alpha particles passed, it has a lot of empty space. Very few alpha particles suffer deflection. So because it is because the positive charge occupies very small area inside the atom, and since some of the alpha particles, very few alpha particles have suffered deflection at greater angles, it is because the entire mass of the atom resides in this small portion. So the entire positive charge will be there in this small portion. So this particular model of atom is nuclear model of atom. So Rutherford has given us the nuclear model of an atom. So what he said is, a nucleus occupies small area, very small area inside the atom. So his model of atom, Rutherford model of atom. All the positive charge protons are present inside the nucleus of an atom. Nucleus size is very small when compared with the size of, then the electrons would revolve around the nucleus. Why would the electrons revolve, or why do the electrons revolve around the nucleus? So if the electrons are stable or stationary, they would be definitely attracted by the strong electrostatic force of attraction between the positive and negative charges. To escape the electrostatic force of attraction, these electrons would start moving around the nucleus with large velocities. They would move along the, they would revolve around about the nucleus with high velocities. So this is the nuclear model of Rutherford. So this model is also called as planetary model. Drawbacks of this model. Where did this model particularly fail? So this model failed in two cases. One, when these electrons revolve, the distribution of the electrons and the energies of the electrons are completely ignored. The distribution and the energy of the electrons are completely ignored in this model. The second drawback is very important one, where if a charged particle continuously moves with higher velocities in a circular motion. Since circular motion, at every point there is a change in direction. The change in direction is due to the centripetal force. So under the influence of centripetal force, this charge, whatever the charge particle has, will be emitted in the form of radiations. As a result, slowly the electron would lose the energy, and instead of following the circular orbit, it would slowly shrink, or it would follow the spiral orbit and would shrink into the nucleus. So that is the second drawback. So when a charged electron moves around with high velocities, so it in a circular path, it continuously undergoes an accelerated motion. As a result, it loses its energy, and instead of following the circular orbit, it is going to follow the spiral path, and it would end up in the nucleus. Finally, it will fall into the nucleus. As a result, the complete matter which we are seeing in around us would shrink. So these are the two drawbacks of Rutherford model of an atom. Okay, thank you very much everyone. We will meet in the next session.